and why we are learning this new topic, that is multi-threading. Let us understand in depth what the threading is and why the threading is. The first thing is like, do you know programming? Do you know how to improve the speed of execution? Can you execute multiple functions at the same time? And are you interested to write multi-thread program in the Python? If yes, let's join with me now. Let us understand what is our today's agenda. Today's agenda is to understand first what the threading is all about and what the threading life cycle is. We'll also be writing the program. We'll be creating the threads, and we'll see like how the thread life cycle work with the program. Here we are going to use Python scripting. We'll also understand the thread models and what else are the thread models are there. We'll be going a little bit detail about understanding the logging and debugging of the thread also. And then we'll understand thread locking mechanism. In all scenario, we are going to understand with practically. Prior to this workshop, we had some workshop, like the previous workshop was on built-in function. My request to all of you, please look at that workshop where we understood how you can reduce the lines of code using the built-in functions. And also in this workshop, I have covered list comparison and dictionary comparison other than the built-in function. One more workshop I have conducted, it was on regular expression, where I have conducted the case study of regular expression. In this workshop, I have used a regular expression model like RE, and also the models like file input, globe models, and using all these models, I could extract the data from hundreds of files and generate the report. What all extraction is done is like email address pattern, account number, mobile number, all these things were extracted and the result was generated or report was generated. One more workshop I have conducted, that was the first workshop, that is Python for everyone. This workshop is for those who are new to the Python and they wanted to understand what the Python is all about in detail. So here, this was the workshop, which was the first workshop where I have conducted almost for 3 hours. Here I have covered all the concept like what the Python is, why Python, who can use a Python, and all details. If you go through this workshop, you'll come to know the basic about the Python here. So this is a workshop for beginner. Next, we have conducted a little bit advanced, where I have covered object-oriented programming in the Python. After that, I have written one application also. That was a more advanced level, where I have covered object-oriented programming, and in that, bank applications was developed using the object-oriented programming. Next thing is, now let us come to our today agenda, and that is threading. This is a threading which is related to Python threading. Okay, it's a multi-threading now. Let us understand what the multi-threading and what the threading is all about. To understand the threading, we need to understand process. And what is process? If you understand, if you can answer what is the process, you can answer the next topic also, like this, what is thread also. So we'll go step by step here. Can you tell me what is process now? Now, there is a definition. If you look at the definition, the process is nothing but the program in execution. So what is program? Program is nothing but the set of instruction. And then if I say process is a program in execution, then what is thread here? So thread is nothing but is a lightweight process, is one of the definition. But if I had to understand practically what the thread is all about, I will say thread is nothing but a function in execution. Each process may have multiple threads. So when you execute one process, means one program, you may have multiple functions into it. And each function execution could be a thread then. We understand what else are the examples in the case of thread now. So what I say thread is nothing but a function in execution. So how the thread looks like, that also I'll show you. What is multi-threading? Multi-threading is defined as the ability of a processor to execute multiple threads now. So if we can execute multiple threads concurrently, it is called multi-threading. So we'll be practicing those examples of multi-threading here now. For instance, you can see this example. There is a one process and it has a multiple threads. And you are trying to execute this concurrently. That is what you can say it is a multi-threading. Now in the multi-threading, you will see the topic like context switching, where there is a frequency switching between the threads takes place. There is a topic like here, in this case, what happened here, even the state of thread is also saved. And it happens by interrupt. So context switching takes place between the thread, which this happens frequently. And that is what, and that is the reason we are able to perform many more tasks parallelly here. So this is one like example where I can show like what is a single thread and what is multi-thread. Single thread is like you have one process and you have one thread into it. Now thread also is having some other things like it share the, see like thread is a part of process. So thread doesn't have separate memory allocation. It takes the same memory which is there given to the process. And that's a benefit here. So here we are saving a huge amount of memory because we are not allocating a separate memory here. Now you can see the example here like how the multi-thread is there. Multi-thread means you have a multiple threads in one process, whereas single thread means you have a one thread in a one process here. So let us come with the practical thing now, and then again we'll come back to detailed theory about the threading. So here I'll be covering the practical part of the multi-threading. So let me start with Anaconda. So to use the thread, what we need to do is to write, we need to import the threading models. In Python, we have a model called threading. You simply say import threading, and you can look at in the threading models, there are many more things. Like let me show, like if you just say dir of threading, you will see there are various attributes in the threading model itself. So what are the sub models are there, that also we need to know, since we'll be using these models now. So what are the models are there in the threadings? Let us look at it. In the threading itself, there are some other things like you can see here, some of the attribute, look at it, the attribute here. We have a lock as a class or a sub model, you can say. We have event, we have conditional threads. We'll be using some of the thread here. Like there is a one of the class in that from the thread model itself we'll be using is a thread here. So this is a thread class which I'll be using to create a thread now. So first thing is just check what is there in the threading model. So threading models includes various classes. In that, event is a class, lock is a class, rlock is a class, and these all the classes are already available. And that way you can create different types of thread using the varieties of the classes available. So here one of the class which we'll be using is a thread class to create a thread. Then what the thread class include? So for that you just need to do what threading.thread, and you can see what the thread class include. So thread class is having various method. For example, we have a method like get name, Daemon, is alive, is Daemon, so this kind of methods are available in the case of thread itself. So whenever I'm using this method, you should understand like it's a part of the class. So they are when you say object programming, we have classes and we have methods. So these are the methods we'll be using while working on the thread now. So how do you write a program? Very, very simple program. Let us start with a very simple program to understand the thread now. Here I wrote a two function. The function is like hello function here. I just say hello name. You write whatever it's like hello and this another Python function. So you write whatever, just like for example, you would like to have the you like to call the two functions now. So how to do that? Simply you have to say df and the function name and the parameter whichever you want to pass it. This is what we know the Python, like very simple thing. Just this is one hello function we wrote. We pass the parameter here name, and now here you can say what is the parameter you want to say. So this is one function we wrote it now after importing the thread. Next thing what we done is we are written another function that is hi, and you can just say hi and whatever the name. So this is just like two functions. And what we are trying to do is we are trying to call this function by creating the thread now. So how to do that? For that, here I'm doing what? Here I'm creating the thread now. So thread is created by using the thread class now. So what is th1 here? th1 is an object. th1 is an object of the thread class. Now you need to pass certain argument here. So which are those arguments which are passing here? Here the first argument is a target. Means which particular functions you are going to call. So here I'm calling this function. You may write one more function here and you call it. That's fine. So your whichever the function you want to call, you simply write in the target. Target is what? Argument, which is a default argument, and you're passing the value for it. The another default argument is a name. What we're doing in this case, name. Here target is a function name, and name is a what we are giving to the thread name. We are giving the name to the thread now. And this could be anything. You want to give the hello, because if you do not give it, what will happen in that case? Okay, let me show that what if you do not give the hello name, then we'll have a default name in that case. You will have a thread 0, thread 1. So that's not like a, maybe I can remove it and then you understand like how does it work. So let me do that. So let us do this as a with argument now without passing any parameter. So that's not a mandatory one. If you don't pass it, there is a default value for that. In all cases, you will see there are some default values are there. So by default, your function will get called here as a hello. As a target is very important in this case, that we need to tell that which particular functions you are going to call. The second thing is argument. Now you are going to pass the argument here now. So argument is passed, like here we are going to pass Surendra here, and what it is saying in the tuple. Now you may pass multiple argument. Right now we have just one argument. If you want to pass more than one argument, you can pass it here now. And now these other things, like I have created one list to just to observe, just to know what the thread is all about, just to know like, okay, this is a list now. If I want to append the list, append is like a method of list now. List is a mutable data structure, and here this is not related to thread now. What I'm doing, this append method, it is nothing related to thread. It is just like I want to store this object th1. th1 is what? The thread object we just now created. And if I want to store that into the thread in the list, just want to store and see like how does it look, what is the kind of output it is. So that's the only reason I added the list here. Otherwise there is no need of list here to create a thread. We create a thread by simply saying that th1 equal to threading.thread and the given the target as a thread name and the argument here. Next thing is, you want to do something like as a threading lifecycle, you need to start the threads or you need to run the threads. So these are the various process which are methods which we need to do. Now when you say start the threads, what exactly happened, that also we are going to observe, and we are going to add the data into the thread here. So we'll see the initial process, how the thread start, how the thread wait for certain process. So the entire life cycle we are going to understand after this program itself. So that time you'll understand what exactly thread start means, what time the thread join means, or what exactly the thread waiting means. Step by step we are going to understand it. Now here one more thread you can see created, like this is a one thread, and we just added the thread, we just started, and the second thread we are created where we are calling the target thread as a hi. So here we are putting the also argument name equal to hi. This is the name to the thread. So we will see the difference like with name and without name. So you will understand, okay, this is the way it works now. And here again I'm appending the thread object into the thread list we just now created. So thread list is just user defined. This is like we created right now. We just initialize and we are created. Now how to run this thread? For doing this, you simply need to let's say you write the program name here. Let me write it percentage write file thread name 1.py, and let me run this. First let me let me see, because there's a double percentage, I just forgot to use a double percentage. Yeah, so this is the way you need to write the file, and now thread name file is ready. Now you can execute from any location. Now if you want to execute from the console, you can execute console. or if you want to execute from the same notebook, yes, you can. So let us run it by saying the run thread name 1.py. Let us see. What you see here, you can see the name hello Mr. Surendra and hi Mr. Surendra. This is the way it returning now. Now, if you want to print the thread list, because now we saw like the threads are executed, but you like to see like what exactly the thread list is included now. So let us see in the backend. So that's why I have created the thread list now. So here I'm going to print the thread list. And let me run once again. What you see now, you can see that hello Mr. Surendra, that's something which is our output of the thread which we just executed. These two threads we executed now. But in the initial stage here, you will see there is something called thread 5 and then started, because I'm running this in the Anaconda. Here it will keep every ID as a unique ID. So it has given its own unique ID for that thread now. The process has given that. So you can see here there's no specific name. I don't know what thread 5 is now. So for that we need to give the name here. Whereas the second thread, if you look at it here, it is say hi, because we are given the name here. So this is what the way you can give the name. Now here you can see there's a name hi, whereas here there is no name. So let us give the name now and see, understand how the name works now. So the name is whatever you want to say. Because our thread name is hello, we are just giving. So it could be anything. It's just like a name to the thread to understand this is what thread is. And then that way you can control the thread now. So let me now execute one more times and see how does it work. Okay, so there is something syntax here. Okay, I just forgot to put the comma here. Remember, whenever we add some modification, we need to understand the comma, space, everything perfectly in the Python. That way, we need to follow certain rules here now. Okay, and fine, no problem. So let us execute one more times. Yes, now it's perfect. So what do you see now? Now instead of thread 5, you have a specific name, and it is giving the name of the thread, that is hello. So this way, like, okay, this is a thread started and there's stop also. Now how the things are happening, this is what the internal thing. Although you may not be interested what's happening internally or behind the scene, that's okay. But then I just want to check, like, if I start the thread, what happened? And if I run the thread, what happened? So in that case, I would like to test it. Okay, now we just started the thread. We also check like what happened if I run the thread, because thread you can either start or you can run. And what the start also do, start also run the thread only. But start you can have control after that. If you want the state, if you want the thread to be wait for some times, or you can want to put the thread into sleep mode, that all things are possible when you have a start. But when you say run means it does immediately execute it. So that also we are going to check it. So let us do a small change in this program now. Let us put here run. Instead of start, let us put the run here now. And see the change. And I'll be saving this program by, let's say, 2. Just test it now and see thread name 2.py. So now you can see the difference here. In the run case, if you see the backend, what's happening? It has just started and there's nothing like if you see the output, let us observe the output here. It is saying that thread, hello, stop, and there is some unique ID created here, something which is there. But here you can see it is just saying the initial. So this is what the difference when you run the thread and when you start the thread. But let me do one thing here. When you say start the thread, that's one of the state of the thread here. And when you say run, again, it's the execution. So this is a part of lifecycle, and we'll need to understand what the thread lifecycle for that. So let me show you the thread lifecycle also. Okay, so let me start this. So what you see, there is a thread is having the thread lifecycle. Let me show the diagram, which is related to thread lifecycle. So here there is a thread lifecycle. You can see the thread is having the various state here. It thread get born means you created. Just now you created the, by using the threading.thread, you created the threads and you just started here. You say like, okay, now you start, the thread is started, and that's what the born thread means here. What else you can have after that? Let's say the thread is born now. The thread is ready for running also. So now you are executing immediately. So it's ready for running once it born. So it like when you say run, it is immediately running in that case. When it says start, it is born and then it is ready for run. And it may now enter into various mode. So what are the modes it may enter is like, it may the thread may go into the waiting mode, thread may go into sleeping mode, or thread could be a dead threads, or it is a block threads. We'll understand, because this is like how it works in the process also. To understand the thread, if you have the background of process, the way the process run and process is having a various stage, the similar way is in the thread also. So here in this case, start method in this case is in the ready state. And when the run thread is there, it implements the task that the thread perform, which includes the GIL, that is a global interpreter lock, which enter into the running state here. And thread enter into dead state when its run method returns or terminates. So if it is, when you say a thread is like terminated, so it is like you block the threads. So in that case, you can say there is a one state called dead state is also available. We'll also see like when the thread goes into dead state, what is a daemon thread, all those things we'll be understanding. So one more thing about Python here, that Python interpreter controls all the program as a threads. Now you must have seen like right now Python is an interpreter, and this interpreter is also a thread program again. And what that interpreter is, we call global interpreter lock. This Python interpreter lock ensure that interpreter runs only one thread at given time only. So this is what we saw. Now we also discussed like threading.thread as a model. Now let us go ahead with a more practical part. So some more demo I'll be showing here. Before, okay, let me go to the concept part more and then come back to the more practical. So some more concept part with a hands-on. So here, let me show like what else are the thing you can do in the Python, and then I'll show one more demo about threading here. In this case, I have shown like, okay, how you can give the name to the threads and how you can call it. But there are some other things. Let's say you want to get the name by just the thread. So there is method available like threading.currentThread.getName. So this kind of method also available in the Python here. So here I have some other program also, and then I'll be showing some of the demo from it. For example, I would like to create a log here. How to create a logging threads? You need to use a model called logging, and using the models logging, you can create a log. So there is a model logging, and in that you have various levels in the logging. So to understand logging, you need to understand what all the various types of logs are there. Like we have debug log, we have info log, so there are criticals log. So when do you use a thread logging? Thread logging is something where you are trying to monitor, or you want to find out, okay, what's going on in the backend. You want to debug the threads. You want to see like when the particular thread started, when the particular function executed. So if you want to monitor, in that case, you are going for the logging. So if you want, it all depends on kind of message you want to generate. Logging allows you to generate the different types of messages. For example, you would like to create a critical message. You can use a logging message for critical message also. You would like to debug message. So various levels are available in the logging itself. So one of the level which is very much is used in the thread is a logging.debug here. So this allows you to generate one report where you want to know, okay, this is the way the thread started and this is the way the thread exited. So there is a method called logging.debug, which allows you to start, allows you to exit also. Now, what exactly here it is now? In this case, I'm using the one of the method in the logging, that is basic config. In the basic config, what you can do is you can provide how the particular message should be printed by giving the specific format now. I will show you many more examples of this logging itself, so that you understand, okay, this is the way I would like to generate the logs while running the threads. Now, what happened in the real-time scenario? You are running the hundreds of, or maybe more than that, threads now. Hundreds of functions you are trying to run at the same time. Now you need to find out which are the critical one, what is going on in the backend. You want to check which particular thread started, which particular thread is exited, which is not running, which is running. All these things you would like to find out. Now, how do you find out? You can find out by two ways. One is to create a log information in in the case of by running on the command prompt. The another could be it is to run in the running the file itself. So this log information can be added in the file or can be added in the console itself. So both the things are possible. In this case, what I'm doing is here I'm running this in the console itself, and then you can see the result how this particular thread works. So let me show the demo of this, and then I'll come back to some more parameters which are there in the case of logging itself. So this program can be saved here. I have created some real-time example like file handling, then how we can do using the file handling. That also I'll be showing it. So this is let's say save this. Okay, I again forgot to use a percentage. You got 2 times percentage here. So let us see. Okay, I again did a mistake here. Okay, let me correct it. Okay, so what you see here now, let us observe the result. Now I can see which particular thread started, when it started, when it is exited. All this is visible to you now. So now here we have a thread names like worker, thread 4 and my service. Now you must be observing like, okay, why there is a thread 4? Because in this case, thread 4 is something a name which is given by the Python itself. So that's not a name we are given. Whereas the thread like my service is given by us. That's the name we are given. Worker we are given. But in the W2, if you look at this WT, there is a worker thread again, where we are not given the name. And that's why here the name thread 4 has come now. So in this case, you can, the report what is generated here is nothing but the report is like a level name is here now debug. Here there is a thread name. Let me tell you, these all parameter whatever you are using right now, they are already defined. You need to see in the model like logging. In the logging basic configuration, what are the parameters which are already available, which are the variables which are already defined, because these variables are already defined. We are just using it like to get the level name. We are using the level name as a variable. So and then if you are going for the thread name, this is also predefined, even the message also. So here thread name is something whichever you are given, that will come here, and there is a spacing now. What exactly you are seeing the format? Format is again in Python we have a way of printing the message in a proper format. It's a method allows you to format. So in the case of logging, there is a way to print the message now. So that format is defined in the case of the format variable, and we are given the value. Okay, this is the way I would like to print the message, where I would like to print the level name, then thread name, then I like to give the space properly, and then the message. So as a result, what you see in this case, we have a space also after the thread name, and that's why you can see there's a space here now. So this 10, what you see 10s is that much of space given to that particular thread name. And then there's a message which is percentage message. You can see here This is what it's saying. Now it is telling you status now. From where it is coming, this status is coming from here. Now logging.debug, this is the message you are returned. So you change the message. Okay, started worker, you can say worker worker thread started. You can say worker thread exit. So anything could be, there could be anything, like you have some function, you want to check it. So here worker thread exiting. Here my service starting. So my service is a thread name, and you want to say my service thread is starting. Similarly, my service is exiting. So these are the two functions. And now let me tell you, this function could be any function, not necessary, because they are just like we wrote as a sample example here. And here you decide, okay, you want a file handling program, because I have written one case study where I'm writing one file where I'm opening one file as a one thread. Second thing is I'm writing data into the file as another thread. Third thing is I'm appending the file as a third thread. So this kind of threads or functions can be written, and then you can call it. Okay, this is a file. I want to read the files. I want to write the file. So this all thing can be executed by the thread itself. Now here I have just modified to tell you like what exactly happening in the program. Here we are trying to see the logs of the thread here. The logs are shown here in the form of debug. Now debug is having now what debugging you are doing in this case, you are checking when the particular thread started, when the particular thread exited, and there is a delay now. We just added the time.sleep. What is this time.sleep? It is just added the delay now. The delay is something here of 2 seconds, and then after 2 seconds, it is going to exit the thread. So here you can see 3 threads. See, we wrote a 2 function, but one thread we call one more times. That is worker thread we call one more times. Whereas in the case of worker thread in the W2, what we did is we did not give a name also. So that's why just to check like what the default name is. So let us see the changes now. We just modify the script, and let us see how does it work now. So you can see now the message is modified. Previously it was just saying the worker started. Now you know like this worker thread started worker. So here this message is coming. This is what the message is. I hope it is clear now that what the level name means, what the thread name means, and what the message means now. I can see some question here. Let me check if anybody is having the question. Okay, so if you want to see the thread, you can print it outside also from the console. On the times we can print the time scale, but there are Python case. We have several other utility available to see the graphically. But right now in this model we are not using that graphical utility available because that's a separate model itself. For this, what we are doing is right now just console-based programming. For graphical utility, we need to go for the GUI programming. So that's why in this particular example, graphical utility won't be available. But yes, there is a graphical utility available in the Python to see whatever the changes are happening in the thread also. Yes, option is there. But for that, we have separate models which we need to, like maybe a GUI programming you need to go, or web programming you need to go there. See, graphics means here is either GUI programming or you have to go for the web programming only. I think I answered the. Okay, so the question here is, can we use a thread? Like, do we have any utility to print the thread on the time scale? Can you print the thread on the time scale? The answer is yes, we can, but the only thing is we need to use a specific graphical utility for that. And for graphical utility, we need to go for the GUI programming, or you want to go for the web programming. In the case of console programming, these graphical utilities are not available. I hope I answered the question. So here again there is a time scale. Okay, one more question is like, can we see the when the particular thread started? What is the time it started? What the time it is end? Yes, there are parameters for that to see the start time and end time also. That also I'll be showing it in another example. So let me show that example also so that you understand. I'm like to so that you understand like the start time and end time automatically. Yeah, there are some. Okay, prior to that, yeah, let me finish one more topic here before I show the some more format of the threading here. The one more thing is like, okay, do we know like we have a daemon thread also? Like we have process. In the process, we say there is a process called a daemon process. So what exactly is a daemon process now? What is daemon process? Daemon process is something which is running in the backend, something which is very important process. For example, you're running the shell command. You're running the shell command, but then shell, whichever shell, maybe a K shell, C shell, whichever the shell you're running, that shell itself is a daemon process. Because unless and until you start the shell, you are not able to run the process. Like ls is a command. Now ls command you can run only when there's a shell running now. So this is a simple example to understand what the daemon. So daemon. Now in this case, one more thing. Let's say your database, you're running on the database command or database query. But to run the database query, you need to have a SQL process running, like MySQL services are running. So there's a MySQL daemon now. So you need to have MySQL daemon, then only you can run the MySQL queries. Similarly, in the thread also, we have a daemon thread which is running in the backend. Now, this kind of threads should be running in the beginning, then only you can run the other. So there are dependency of the other thread then. So other threads are dependent on the daemon thread. So daemon thread which is running for a long time, like the same way for the you can say the process case also. So daemon process also running for the long time. One more thing here, how important is the daemon thread, how important daemon process? So let me know they are the most important, because with that only they are the backend process, or these are the process which are running the backend. That's why we are able to run the application based services. So applications are depend on daemon threads or daemon process itself. Now which threads are the daemon threads? Mostly the kernel based threads are daemon threads, whereas user based threads are the threads which are user defined threads only. So there are kernel based threads and there are user defined based thread also. So now here I'm just showing you like how do you know whether the particular thread or let's say there's a thread which is a daemon thread. Right now we are not having this example as a daemon thread, but just there's a method available in the Python library to check if any process is running in the backend or whether that particular thread is running or not, whether it is live or not. That also you can check it. So how do you create a daemon thread? So there is a method available in the Python again, that is set daemon. In case you want to make one particular thread running in the backend for a long time, and that's your programming requirement. With in that case, how to create a daemon thread? You need to create, okay, this is a program, it should be running for the long term, the duration should be a little bit more as compared to other thread, because all other threads are depend on the, let's say, your daemon thread. So what you can do is you can set the daemon thread in that case. So how we are done in this program, let us see now. Here we wrote one of the function name, just again user defined function name. We are giving the function name, let's say daemon now. Now in this case, what we are done, we are just saying like, okay, logging.debug, and logging.debug, we just say as you know, this is just to start the it's just the message. Okay, this is a debug. You are saying, okay, this daemon process started. So let me write here the daemon thread started. Daemon starting and daemon thread exiting. Okay, so here this is one thread which is daemon thread, where we added what? Time.sleep. So purposefully we added more time in this case. This is just demo, but this is not exactly daemon thread here, just to test now. In this case, what particular method is there to set the daemon? If you want to make particular function to run for a long time, this is what we're doing manually. So let me tell you, this is not a the real daemon thread right now. But real daemon is, as I said, like there's a process which is like let's say if you want to create such a process which should be running for the long term, that is possible using the set daemon. So here we created one thread here. We just given the name here as a, let's say you want to give the name as a daemon 1, and just to understand, like, okay, this is a daemon 1, and here we just call the method set daemon. So let us see what we have done. We are given the name here. It could be any name. Now it's just given the daemon thread here. It could be daemon thread, and just call the target thread is this one, daemon. Now here important thing is this method set daemon. And one more thread we are creating is a non-daemon. Non-daemon is just like a we can say a thread which is not going to be running in the backend for long term. So it is just a simple thread now. So we are just putting that without putting the time. But then if you want to put the time, you can just put for maybe a small duration. Maybe 1 second here, that's fine. And in this case, I'm just saying this thread as a non-daemon. So again, it's like an object. You want to create something else, you can create it. Non-daemon 1. Now run this by starting the daemon thread. How do you start? This is the way we start it. This is the way we end it. Okay, this is a start. And then we want to save this program now. Let me save this program as a double %. And I will just say daemon. Okay, this is just name of the file. And let's see how does the daemon thread works now. Mostly we should execute such program in the backend, like in the console itself. So let me run this. Run thread daemon.example. Okay, let me check the spelling mistake. Yeah, thread daemon. Okay, just run. I'm just running it. Let us see. Okay, there is some mistake here in the spelling mistake. Where I did it in the name. Somewhere I did a mistake in the typo error. Okay, here. We have to be very careful in typing. Yeah, let us see now one more times. Yeah, you can see now. So here it's saying the daemon thread started, and then you can see non-daemon status started and exit also, and then daemon. So here, what was happening? Daemon thread was running for longer duration. It did not exit before non-daemon thread. So that's a benefit of you can say daemon thread here. So that in case you want some thread to be executed for longer duration in the backend, you can do it. So let me see some questions here again. Like there are some questions here. Okay, so now you understand here that when you talk about the daemon thread is having the highest priority. Why? Because these threads are running in the backend, and user-based thread, and these are the threads which are running in the kernel. So there is a one question which has come like, okay, which particular thread is having the highest priority? So whether it is a user-defined thread or the kernel thread. So let me tell you the obvious answer here is a kernel-based thread. So when there is a kernel-based thread is having the highest priority, and then when it's a user-defined thread is having a little lower priority. So this is very important to understand. In the same way in the process also, whenever you say kernel based process is having the highest priority as compared to the user based process here. Okay, so this was to give the like how the daemon thread works, and also shown the like and how do you set the daemon here now, daemon thread. So I will show something example where okay, let me show some good real-time example before we even before we start the synchronization program. Yeah, I have written some program. Okay, let me show a very good example of the thread itself which I have created. We'll take here a 2-minute break, and then after 2 minutes I'll be start resuming the session. Meanwhile, you can just write your question so that I can answer it. Okay, so we'll be starting once again. Now here we are going to see a real-time example that how we can create a simple program, like let's say you want to do the file handling using the thread. So we are going to see that kind of a example using the thread itself. So let me start with that example now. Here what I'm doing, here I'm writing the function like we saw in the previous workshop, like how do you create a file, how do you write the content to the file, and then same case study I'll be continuing with a various you can say the by creating the different types of thread itself. So let's say let us write one function where the function is like to create a file now. So they're very simple and straightforward to understand. Like, okay, here we did what one file created is a Cisco file .txt, just the name of the file. You can write whatever the file name is you want, and this particular function is to just to create a file now, and we are just printing the message that file is created. So this is a very simple function. Then second function which I wrote is a read file. Now in this case, these two function I would like to call as a thread now. So how to do that? For that, I'm writing one thread name is like a thread file create. Now in the thread file create, I'm simply doing what threading.thread and given the name like a create underscore file, and calling here this is like a calling the thread, that is a function create underscore file, and given the name that is create underscore file. So this is the name of the thread here. Now in this example we do not have any argument to pass, so that's why what you see here that the argument is not passed in this case. In the previous example we saw that we have passed the argument. So it all optional parameters. Whatever the parameter you are seeing here, they are optional now. Now you can just say run the thread and see like whether it creates a file or not, whether it reads the content of the files or not. This is what we are going to check it. So what we are in this case we are doing is, here we are adding some data into the file, and here we are just reading the data file. So these are the very simple. This is just like how you can use a thread here, and let us try to run it now. So here the example thread file. Just let me run it and see how does it work. So you can see it is saying that file is created, and this is a Cisco file, and this the file is ready. So now this is simple, very simple example to apply whatever we just now saw it. So previously we just saw like the simple example, like we created two function. Now here in this case we are trying to apply it like for the file creation as well as for reading the file. Now can you create one more thread for appending and try to apply it? So let us try that also. Let us try one more thread where you are appending the file now. For that, what we are going to do is, in this case you can create a file. You can also read the file, and you can see one more function you can write it, that is append the file. Now but what if I append? I would like to check now whether the data is added into the file or not. So for that, you can also check read appended file. So in this case, what I did is I wrote a function, four function, one function to read the file, one function to write the file, one function to append, and one function to read the appended file. So these four functions we are done. So they are the four thread itself now. So we have created the four thread now. To create, we write a one create threads, then to read, we have read threads, and then we have appended threads, and we are running all these thread now. So this is one example like how you can apply and check it. Okay, just try a simple example here and see whether it execute or not. Now let me show the demo, and you can see like how does it work. In this case, it's a thread file 2, and you can see now it is saying that file is created, and then we are reading the file, then file is appended. So this is the statement added now. The file is appended, and then we have again read the file, read the appended file. So these all four threads we have just call it. So this is a very simple way to understand how you can apply your the basic thread concept in a file handling also. Now next thing is like, what about logging? I want you to show it logging in little bit detail, because if I'm using a model like logging, I should know what the logging is all about. So here there's a, in the Python there's a one library called logging available, by which you can generate the log. So how the log file is created now? The log file is created by simply using the model logging itself. In this we have a parameter available like file name. You can just say logging.basic config, and you can pass the parameter as a file name as a log file, and you can give the level also. Now in the log file, if you go in detail, there are various levels. As I say, there's a debug level, there's an info level, critical level. So various levels are there, and based on the levels you do have a message also. So here in this case, you can add the message into that log file based on the various level also. And this is one simple, or you can see the test example by which you can understand how the particular log file can be created. In case those who want to try it out, you can run this program in the console and check it out. So let me write this program as a logging example, as a this is just to tell you like how the logging works in the Python. So let me write this program. And let us see it. By executing by run command. And you can see this is the way the file, because this file I've been running several times, you can see that whenever I'm executing, it is keep on appending the data. So the message is getting appended automatically. So and you can see various log also, like debug log is created. You can say root started, root exited, whatever is there. So this is the way the logging file can be created. Now let us go ahead for the thread logging, which I just now said, like already taken this example. So can we add this example in the file handling? Whatever we saw in the case of thread logging, can we try in the case of like in the file handling also? Yes, you can try it out. Here I did what? In this case, I created the logging.debug for the starting the file creation. Here now file handling as well as logging is added now. So previous example we saw like how the logging works, and now in this example what I did is just applied logging.debug that I want to check whether the file is created or not. So this is the one thread now I want to check it. Then if that's the message I want to see. Then second thing is I want to check, okay, now whether I'm able to, whether the thread that is the reading the file thread started or not. So this also we can check it now. So here I will able to generate the log message in this case. So one more thing is for the append, whether the appending of the file is started or not. You can check it in the by just writing the login.debug, and also to read the append file. So this is what was a one case study to understand, like, okay, how you can apply your threading concept, where we are understanding the threading is like a threading.debug, and then here we are doing the how do you debug the thread here. So here logging is helping you to debug the thread now. So this is another models of the Python which we are using along with the thread. So thread allows you to create a thread, whereas logging is allowed to see the thread status, what is and the thread messages. We have a critical message or debug message, and observe the thread status itself. So you try to apply this example at your end also and see like whether it works perfectly or not. So here again the parameters are same. Look at the first thread now. For first thread I just say create a file. The second thread I said to read the files, and then third thread I said to append the files, and the fourth one is to read the appended file. So let us see now how does it work. Okay, the file name is thread file logging, and now let us see. So I hope I not overwrite this file. Okay, here showing the file is created, and okay, let me check this in the one more times. I had to overwrite this file because this file was already overwritten, or in the console we can check it. And let us see now what happened in the backend. How to check in the backend what's happening? This program will run from the command prompt now. That is thread file underscore logging. Let us see what's happening in the backend now. Let me run in the console. Okay, there's a console part. Okay, the program is thread file. Let me check the location. Show with the run now. And now this time example is thread file log. It's running in the backend. The first thing is the file is created now. Then it is appended. Okay, that's the only thing which we are doing. But to see the console, I have to see the command prompt only right now. So let me show that in the command prompt also. The GUI is not allowing to show me the exact result. So this program status is available in the I think there's some problem here. One more time, so I'll try to share the screen. You can see the result here. This is the screen. This is what when you see the in the backend. So something in the UI you are not able to see it. I would like to show. I hope now the screen is visible. Now this is what happening in the backend. Here we are doing what? In this case, we are running this threading underscore logging 2. This is the file where we can see that starting the created file thread, then ending, and then one by one we can see now here the result. So this is what I want to show it, but then it was not showing in the UI part. In the console, you can see it. Fine. So I hope now, okay, let me show the another screen now. Okay, I hope it is clear like how does the logging with the file handling works now. So let me know if any question is there. Okay, I can see there are no more question right now. Fine. So let us see now the next thing. Again, I have discussed about the daemon thread. You can see how the daemon thread works and non-daemon thread. And okay, but then one question is like in the daemon thread, if you want to check whether the particular thread is alive or not, how to check it? So there is a method available called daemon thread.isAlive. And when do you want to check it? For example, you have a multiple threads now, and you want the particular thread should be available, and you want to check whether that particular and that it has the highest priority also, because other threads are having the dependency on that daemon thread, and you want to check whether that particular thread is alive or not. So in that case, you have a method available called daemon thread dot is alive. So daemon thread we created here now. We saw it last time also what the daemon thread is. Now in this case, we are saying daemon thread is alive to just check whether it is and it's just going to say true or false only. So this is a program. Again, I will show it. Daemon thread is alive. This is a program. Let me show it on the console again. I have to again run this with a different console and show like how does it work now. Running this program from the command prompt again. Okay, so I'm just sharing the screens one more times with a different console, and you can see how does this work now. Here it say that is the thread alive or not, and because we run the command is daemon thread, so you can see here it's saying the true. Okay, so this is what the program was. Daemon thread is alive. Now let us go for something which is related to threading synchronization. Now this was about to understand. Okay, the sharing screen again I have to modify. Okay, so I hope you understood like how the daemon thread status can be checked by using the method called isAlive. Now, very important topic to understand, and that is thread synchronization. What we saw till now is to how do you create a thread. Let me summarize what we saw till now, and then we'll understand the thread synchronization topic, because it's a little bit big topic than the what we saw till now. But before we start with the thread synchronization, let us understand what we saw till now. So what is thread now? Thread is not just like a someone say like thread is a process in execution or lightweight process here. I will say here, instead of just saying that thread is a lightweight process, I will say thread is like a function in execution. That we understand. Okay, this is the like in the case of a process, we say process is a program in execution for thread, practical definition, you can say is a lightweight process, but it's a, we can say, function in execution. Now when you run one thread, what exactly happen in the, when you are running the thread, what exactly happen? So in one process, you, if you are running one thread, it's a single threaded process. When you are running the multiple thread in a one process itself, is a multi-threaded process. So what is multi-threading here? You are running the multiple thread concurrently. So when you are saying multiple thread you're running concurrently, that is what multi-threading is. Now how to manage? Let's say you imagine you are trying to run multiple thread in a one particular process. Now if you want to do that, what all step you should do it now? For that, you need to have a thread synchronization. Now when you say thread synchronization, what are the way Python allows you to do thread synchronization? So there are various models available for the thread synchronization itself. So one of the models is like conditional thread, where we are going to understand producer and consumer example. Then we also understand the locking mechanism, like can you have the lock, threading lock? We'll see that also. So there are various ways to synchronize the thread. So let us see the example where we are going to have the conditional thread. Now, what is the conditional thread? How do you create conditional thread? For that, there is a method, or you can say the class available in this case, that is threading.condition. Now that's the object here. In the threading.condition, you create a conditional thread. So that is the object where you can have the producer and consumer, where you have one program that is called producer, which produce the threads, and there's a one consumer. Now this what producer thread is doing is making the resources available. For example, you have printer. You want the printer to be available for other, or you want some printer process, you can say you want the printer process to be available, so that you can have the process of printing, or anything you want, any resource, let's say memory, you want the memory to be shared, so you need to make sure that memory is available. Any buffer, let's say you have buffer in the computer, you want to use that buffer, so that buffer, if you, unless it is available, you are not able to process, you're not able to read the data from the buffer, you're not able to write the title buffer. So all these are dependent. So you need to first make sure that whichever the thread you want to make it available, whether it is available or not. So that is all producer. So producer makes sure that that particular resource, it could be anything, is available. So here, for that, I written one function that's a producer, and here we are saying, okay, we want to debug also whether it is started or not. So we are starting the producer thread, and in this case, I'm writing the condition. Now this condition is something here, conditional thread. This is an object now. The condition is a built-in object which is created using the threading.condition. Now threading.condition is something where you're calling the condition method, and this object will allow to hold the particular thread now. So how? Let us see now. So let us create a one thread as a one conditional thread here, passing the argument as a condition in this case. So whatever the function we wrote right now, it's consumer and producer, we are passing the condition here now. So this is a thread which is an object. Now this object we are going to pass it. Now first take is like producer, where this producer is going to make the resource available. The second one is a consumer, which will make sure that is going to consume the resources which are already available. Now how to tell that consumer that you are going to wait now? So this is very important now, that you need to write condition.wait, this method, in the consumer thread or consumer function, whereas you should be writing condition.notify all into the producer. This is very, very important in this case. If you don't write condition.notify all in the producer, consumer will not know whether the resource is available or not. So if you have more than one consumer, what? In all consumer, you just need to say condition.wait. And in the producer, you just need to say notify all. So this is also built-in method available. So with the help of this method, notify all, the producer tell to the consumer that I am the available, and now if you want to use it, yes, the resource is available for you. So this is a program where producer is telling the resource is available and consumer is consuming it now. So which is the method which is used here is very important in this case. In the producer, we use a notify all, and in the consumer we say condition.wait. So these methods are very, very important to understand. This is a method where consumer is waiting, and here producer is notifying. Two consumers. So you may have one consumer, yeah, more than one consumer. What we are to do it now? Okay, these the other two functions we wrote now. Now some more modification I did in this case, that here I also added ASC time, that is to know the system timer. So that also we'll discuss. Now here there are two consumer. We wrote a two function and we are calling this the two threads now, C1 and C2. Now C1 is one consumer, C2 is another consumer now. So we just given the two name, C1 and C2, and so the other conditional threads, and there's a one producer now in this case. So first what we should do is we try to run the consumer and see like what happened, whether the consumer is waiting or not, and then also try to see like whether the producer is started or not. So let us first run this program and check how does the producer and consumer work. So we are just trying to first run it without even let us try to just avoid the you can say sleep time also, and see how does it work first, and then we will run with a sleep time. That's a delay only added just to check like how the things are working. Now let me run this, save this program first. Thread. Mostly this kind of program should be run from the console only. I'm just because there you can see the exact output. Anaconda doesn't support sometimes to execute such kind of program, so we have to be very careful. Whereas in the console, this kind of program can be run now, because whenever we see the program which are ready to do threadings or ready to like so let me run this program from the console only. I will try to share again the screen. I'm running this program from the console again. Okay, so now I'm going to just let me start this console part. Yeah, this is what. Now I hope it is visible. So what I did here, I just say the Python conditional thread.py, and you can see the started consumer thread first, and then we make sure that resource is available and the consumer started consuming it now. Now here again one more time I'm running it just to tell like how it is executed. It's very simple. And you can see C1 and C2 consumer. First time it was showing the C2 and C1. This time C1, C2. Here there's no here there's a like you can say any thread. Like here we're not telling the C1, C2 that which one. The only thing is producer need to first make sure that resource is available now. So let us try to modify the code now and see, because we should see like one by one how consumer is consuming the resources now. Okay, now so here just did a little bit modification that I just wanted to show, added a certain delay so that you know how the things are working now. That's it. So here this is the way you can have the locking mechanism between the thread now. The threading lock, what is the locking mechanism here is that you're asking the first resources to be available before it consumes it. So anything you are sharing here, let's say you are sharing any resource, make sure that the resource is first available, and once the resource is available, then only you ask the consumer to consume it. So that was a demo for the producer and consumer example. Any question here? Let me know. There are other way also to just quickly let us have the other way also of like how you can synchronize it. So there are other models available in the case of Python, like locking mechanism. Other than the producer and consumer, you have a, this is like example of producer and consumer. You can see this is also running now, whichever I executed. It shows like how producer and consumer is running. So here yeah, one more thing you observe in this case, we have some time also, that is ASC time. That's a printing format. You can decide how do you want to print it. Okay, there's an example like what is other way you can have locking mechanism. Locking mechanism is also done by the method that is in the thread itself. Let me show you like the one more thread that is, okay, here there is a one example which will tell you how to create a lock. There is a method called threading.lock. So that this also allows you to have a lock and unlock. So here what happened in this case, it's like a semaphore. In the semaphore, you make the resource available, you are asking for wait for the resource, you're acquiring the lock. So this is this kind of this example you see in the semaphore. So the how do you implement the semaphore in the threading, in the Python threading? So there's a way to do that, that is by using the class like a threading.lock here. Now what we do is we first need to write a class where which include the semaphore implementation. There are seeing the lock acquire and the lock so the how do you create it? So here we need to write one class for the counter itself, which is going to have the increment by 1. So this counter is going to make sure that if you are either you are having the lock acquire or you are releasing the lock here. So there's a the releasing the lock is something which is done finally. So here we are using the try and the finally block. In this case, we are adding the acquiring the lock in the try block, and in the finally we are releasing the lock. So this is one class which is a counter, which is just to increment, and here there's a one class. There's a function called worker. This is the thread name, or you can see the function. And this particular thread we are going to run 2 times. That is by using the for loop here. That is I in a range of 2. And here you are calling this particular worker thread and see how does the counter works. Again, this complete program just like to show you as a demo. But if you try to see in detail, yes, there's a lot of things to understand as a concept part, like what the locking mechanism means, what the semaphore means, how does the increment work. So there's a lot of other concepts also involved when you are going for the thread lock here. So maybe the theory part I have to come back again to understand how the thread lock works here. But this is like one of the way you can lock the thread here. Then okay, so I think uh, for the threading as a theory, I think I have to come back to theory also, because this is just want to show as a demo. Yes, this is the way also you can lock it now. Now I'll be coming back to theory after the maybe a 5-minute break. You can have the question in between, and I'll come back to the theory also. Okay, so this was to just tell you like the session what we are covered till now. Just let me know like we started understanding what the thread is all about. So there is a one. Let me have some poll for that to like to understand your knowledge about the thread now. So I'm just launching the poll now. Let me see like your answer for this poll. My first question to all of you, it is what is thread now? Just select the right answer. The answer, I can see there are responses now. So I just want to check whether you understood the what the thread is all about. The first thing is to know what the thread is. So I can see there's a response. So the options here, those who are just like not aware like what the thread is, the options is whether thread is a program or it is a process or function in execution or process in execution. And I could see the answer given is it's a function in execution. Great. So let me see the another question. What is process now? What is process? So I just started run now. What is process? You have to just select the appropriate answer. It is given the option like whether it is a program or it is a program in execution or function in execution or it's a function. So this is a question of process, not the thread. Previous program was on what is function. Now it is a what is process. So let me tell you that process is program in execution, not the function in execution. Okay, and the next one more question. What is program now? So program is, what is program? Again, a basic question. Yeah, this could be like someone is saying set of functions, someone could say set of instructions, someone says set of data or method. What exactly it is now? So someone say program is a set of functions. What, not necessary, it could be a set of function, but it mostly what you say, the definition is program is set of instruction. So let us see like the instruction could be anything, it could be a function also. So this was to just test like what you know about the program now. So program is a set of instruction, if you want to say, and whereas in program instruction could be anything, it could be a function also. Okay, so that was about like the brief about what now some more question about what we are seeing. I would like to just come back, go back and check it like what all thing we are seeing, and let me explain in more detail. So let me show you something in detail now and tell you what exactly the thread is all about now. So what we started with a very simple thing in this particular workshop, that we understand Python is having the model called thread. This thread model allows you to create a threads, also run the life cycle, like the thread is having the thread life cycle, which is like to create the threads, you want to run the threads, you want to block the threads, you want to ask the thread to wait for the thread, you want to make the thread as a daemon threads, or you like to make the thread as a you want to check the logging of the thread. So this particular workshop we try to understand how you can do this now. So understand the first step is to have a model called import threading. Then once that is done, the next thing is create a threads. So how to create a thread? you can create a thread by very simple thing, that is by class thread itself. So I did what? Threading.thread. Threading.thread, thread is a class which is under the threading models and by which you can create a thread. Now what the thread is nothing but the function in execution. So when you say thread is a function in execution, it means with the help of thread you can run the function, or you can start the function, or you can ask the function to wait, or ask the particular process or function to wait also, or thread to wait, you can say. All this you can do it. So thread is created in the case of, in this case, thread one object is created. Then you are able to call whichever the thread, like I created thread 1 and thread 2. Now we also saw like list method. In this case we try to add the the whatever the thread status is there in the backend, and we are run this thread now. So this was the first example which we tried in the beginning. Then we saw like, in case like, okay, how to run the thread, how to start the thread. If you want to see the how the thread work and how the thread started, you want to check the timing also. Let's say you want to say like when the particular time, at what time the thread is started. So I have added something more in this case, that ASC time, which will tell you when the particular thread is started. So this example will tell you like when the particular thread started, when the particular ended. So the time also can be added. So that for that, sorry, we have the format called date format. Here you can provide hour, minute, and second, and this way you can print it like this is like a ASC time is a parameter by or variable which will allow you to print the time of the thread when it is started and all. So but then format is very important in this case. Without having this proper format, you will not get the specific time here. So here we are given the hours, minute, and second. So this is going to tell you like, okay, this is the time the thread started. So before creating the thread, before running the thread, so these all logs has been created by logging.h. So one more models along with the thread we have taken is a logging models. Then with the help of logging, and also there's a model which added is a time. Time is allowing it to add the delay by some second. So here we wrote one function and just this function here we call the thread also. You can see there is a x equal to threading.thread. We are calling this function and passing the argument to this. What do you want to give it? That's your choice now. And yeah, this is also possible in the thread now. The third thing which we have seen, like let's say you have a multiple threads and how do you execute. So this program I have modified with a multiple thread also, and you can see how the thread, which is your program itself. By default, let me tell you, whenever you are running the thread program, there are 3 threads which are running. One thing is in this example, like the main thread. That's your program itself is a one thread. Your multiple thread program, this is a Python model. That particular program when you're running, that's the main program that itself is a thread. Then under that, then there are 2 more threads. So main thread, and under that there are like a thread 0, thread 1. So these 2 threads we are running now. So this program is for to understand like how you can execute multiple threads and also see the timing here. So yes, there are like locking mechanism, like we can create a locking mechanism. How do you share it? How do you synchronize it? So there are various ways to do it. So this is one example which I created, where this example allows you to share the memory. Now they like test the database. So there's a like you have some variable and you are sharing the same variable with multiple thread. How you can do it by using the thread lock. Yeah, there are various example which where you can practice it to understand the thread. So this is what I want to show you about the thread right now. I hope you understood like the basic example of the thread and how you can apply it, like to create the threads. How do you read the content of the file? Even we have seen the example where we saw like how do you apply the thread skill into file handling. So here I have shown example like, okay, now you can create a threads, you can create a files. Let's say you create a files, you read the content of files, and then this kind of threads can be created and run also. This was the example we have seen, and then what we saw is like complete thing, like where we wrote one thread for the file creation, second to read the files, third to append the files, and then after appending, we want to read the file once again. So this is that example which you saw it. So these are all practice example. Then just to tell you like how the logging files created. So there is a model available, logging in the Python, where by which you can create a logging file also. So this is where you can create the file name. So this could be any name. You can just pass as a parameter file name here, and the log information can be appended into the log file. So this models can be used to create a log file now. And this way it create a output file then. And this logging model was used as a console. If you want to run this program on the console, then you can use the logging.basic config, and then the output will be displayed in the proper format like level name, thread name, and message. So this is also, this for example also we saw it. And also we saw like how to create a daemon thread. Daemon thread is something where the thread runs in the backend. Something which is very important is having the highest priority is like a kernel thread. You can say mostly the kernel threads are written as a daemon thread, and so where like the same way in the process also you have a daemon process. So the process which is running in the backend is called the daemon process. Similarly, in case of the kernel threads, we say the daemon thread here. So is having the highest priority, and after that we have a user defined thread. So mostly when you say thread application, what you see is a application based thread, but in some cases like when you are kernel programming, then only you will see daemon threads are there. But then how do you make sure that the daemon thread is running or not, whether the daemon thread is live or not? So for that we also saw a method called set daemon is alive or not. So first thing is like you need to set the daemon. Second thing is you need to check whether the daemon thread is alive or not. So we saw like there's a one method called is alive to tell you like whether the particular thread is alive or not. So this was about the daemon thread. Then we saw like how exactly the locking mechanism works in the thread. So we have one models available, one of the class available called condition. This is a class. Condition class allows you to create a conditional object. This conditional object allows you to notify as well as ask the consumer to wait. So producer can notify all the consumer threads, and the consumer can wait for the producer. So for this, first thing is what you do is you need to create the conditional object by using the threading.condition, and this object allows you to create a producer as well as consumer and synchronize the various thread now. So here we wrote a producer thread. In this producer thread, we are using the method called notify all. Notify all is a method which will, this is a method which we should be writing only in the producer, not in the consumer. If you are not writing notify all in the producer, then the consumer won't get the message itself that there is a producer thread available or not. So this is very important that you need to tell in the producer notify all so that consumer get the message. And once the consumer get the message, okay, the resource is available, here it is waiting, here there is a condition not wait. So consumer is always waiting for the producer, and as soon as the producer is available, the consumer consume the resources. So this is the way the producer consumer synchronization is possible in the multi-threading now. So here you can run the multiple threads. So you have two consumers in this example and one producer. So this is the way you can have the conditional thread. And in case those who like to go for the semaphore kind of a locking mechanism, there is a method, or you can say class available, that is threading.lock, where you can have the counter, where you can say resources available or not. So it is like for every like you are running the multiple threads now, and you want to make sure that you are sharing some, let's say, space. Let's say there's a one room now available, and that room is available only for one person. So now you cannot have all the person, that's the condition, you cannot have all the person using that room. Now what you will do in that case, you will say, okay, you will check one whether that available or not. If it is available, the room is vacant, you are making it available for others. So but then in a synchronous manner, one by one. So your one person has used, then the it is available or not, it is checked. If available, then given it is given to the next thread. Now so here in this case, this worker, there are 2 to 3, let's say in this case there are 2 threads, or you may have more than 2 threads. Now each thread will get the space now, and it is shared to the, so there is only one space but shared to the multiple thread now. So this is all possible by incrementing. So now one by one, it you know the same space is shared. Now here there is a value, the values is incrementing, and then it acquired and then release the value, it acquired and release the value. So you have one variable in this case, set value, and this variable is being used by multiple threads now. So this is all we call, say this example is for more like, you know, semaphore kind of example, you can say. Okay, so that's it from my side today, and then we'll have some other workshop now. I think here there's a end of our Python workshop for the specific, like the core Python or the basic Python, and some just wanted to give the one advanced topic of threading here. What we'll be starting now is we are going to start the new series of Python, and that is on the semaphore. Sorry, it is for more about the Selenium testing. So we'll be starting this testing part here now. So there we see like the modules related to how do you create a test cases, how do you write a test suite. They're all hands-on will be taken in the case of the another workshop, which will be starting on the 27th of August. So just after the 4 days, we have one more workshop. First, we'll be understanding how to write a test cases, and there we are going to use the object-oriented programming of the Python. Then the next workshop is more on the Selenium. There we are going to see like using the Selenium library, how you can you know, test the various website, and how you can access the elements, or even using the XPath, how do you access the element, how do you fill the forms. All these hands-on will be taken care in the case of Selenium workshop. So thank you very much for attending this workshop. Here I'm going to conclude this workshop now. Let me know if any question is there.